In this lesson, we're going to learn how to solve nonlinear inequalities. But before we get to those, I want to review factoring quadratic expressions. Okay? So when we learned how to solve quadratic equations, we stuck with just the quadratic formula and with completing the square. But some quadratics are actually easier to solve if you can factor them. And these are all situations, these four examples are examples of quadratics that can be factored. Now, the way that you know that a quadratic can be factored is if the number on the end here, the c, if the c is the product of two numbers, that when you add those two numbers together, you get the middle number, b, then it's factorable. Okay, so for example, in this case, 35 is equal to 5 times 7. But 5 plus 7 is equal to 12, and therefore this is factorable. And the way you do it is this, is you have your quadratic, and then when you factor it, it winds up being two binomials in parentheses. We're going to bring down the equals 0. Each one is going to start with an x, and the way that I'm showing you right now, your x squared, a has to be equal to 1. It has to have a coefficient of positive 1. And what you'll do is you'll take the two numbers that multiply to 35, which are positive 7 and positive 5, and we'll put them right here. So plus 7 and plus 5. And then we know that positive 7 plus positive 5 is equal to positive 12. Okay? And so this factored becomes x plus 7 times x plus 5. Okay? I'm also going to show you how to do this on Desmos right after I do these examples. Okay? Now, this one right here is a little different because the product is negative 63, and because it's a negative, it must be one positive number and one negative number. Well, we know that negative 7 times positive 9 equals negative 63. So 9 times negative 7 equals negative 63. But we also know that negative 9 times positive 7 also equals negative 63. And over here, we could have had negative 5 and negative 7, because negative 5 times negative 7 equals positive 35. But if you were to add negative 7 plus negative 5, you would not get positive 12, you would get negative 12. So that's how we know that it was not negative 7 and negative 5. So the question is, how do we know whether it's 9 and negative 7 or negative 9 and 7? Well, we add them together. Negative 9 plus 7 is negative 2. This says positive 2. 9 and negative 7, that's positive 2, so these are our numbers. So we will do x plus 9, because it's positive 9, times x minus 7 equals 0. You can try this one if you want to pause the video. Try this one. So we're looking for two numbers that multiply to negative 40. There are a lot of choices. Negative 4 and 10, 4 and negative 10, 8 and negative 5, or negative 8 and positive 5. So a lot of times there are a bunch of pairs of numbers. You have to pick the right ones. But I can tell you that negative 8 and positive 5, when you add them together, you get negative 3. So this one winds up being x minus 8 times x plus 5 equals 0. And it's because negative 8 plus 5 is equal to negative 3. If we were to put negative 10 and positive 4, negative 10 plus 4 is equal to negative 6, not negative 3. That's how we know that it wound up being this one. Okay? And then here, we're looking for two numbers that multiply to positive 12. Well, we could do 2 and 6. We could do 12 and 1. We could do 3 and 4. Okay, I'm thinking 3 and 4 because 3 plus 4 equals 7. But this is negative 7. And so that makes me think that this is actually going to be negative 3 times negative 4. Negative 3 times negative 4 equals positive 12. But negative 3 plus negative 4 equals negative 7. So I think my two numbers are negative 3 and negative 4. So I'm going to write x minus 3 times x minus 4 equals 0. Okay? Now what I'm going to do is I'm going to break out and I'm going to show you how to do these exact same four ones in Desmos. Okay, so here we are in Desmos. And so our first one was x squared plus 12x plus 35. And look at this. if we go to where the curve crosses over the x-axis and we go to these gray dots here, we get -7. What we have to do is we have to do the opposite. Instead of x minus 7, we got to do x plus 7. We'll do the same thing with this -5. That'll be x plus 5. And so that we know now then that this factors into x plus 7 and x plus 5. The next one we did was x squared plus 2x minus 63. And we had x plus 9 and x minus 7. Well, look, here's a -9, but we reverse the sign to +9. So we have x plus 9, and this is +7. We reverse the sign to -7, and it's x minus 7. So we have x plus 9 times x minus 7. Okay? The third one we did was minus 3x, x squared minus 3x minus 40. And we came up with x minus 8 and x plus 5. Well, look, here's +8. We reverse the sign, and it's x minus 8. Here's -5. We reverse the sign, and it's x plus 5, just like what we found. And then we have x squared minus 7x plus 12, and we had x minus 3 and x minus 4. And look, here we have +3, reverse the sign, and we get x minus 3. +4, reverse the sign, and we get x minus 4. Okay? And that's just a way that you can use Desmos to be able to factor a quadratic equation or a quadratic expression.